I want to make sure that everybody is here though before I go on, or else it's not going to be useful. So how did you go to up here on the top where there's these three bars? If you hit on that, it will give you all the files that are in there, and transform is the one that we want. So if you're using a computer, you do it that way. I think your phone's kind of the same way. It might be, I don't know, it's kind of laid out differently. So one of the things you might want to do at some point in time is set up your own account, because if you start putting things in there that your work, you can save it, give it a name just like anything else, right? But if you don't have an account, then you leave and then you come back in, all your work is gone. So it's sometimes good to have an account. It's free, obviously. So you just create that account and then you can save work in there. And so, yeah, you might want to do that. All right. Where do I go after logging in? So, Kendall, let's see. So you're logged in, right? So then you would go to these three bars over here, and that should pull down a list of documents, and transform is the one we want. Is that help?
My screen looks more like the top of it has like math tools, resources, and then your name, and like there's no graph even.
So do this. Okay, just go to desmos.com, okay, and you'll see it should come up with the graphing calculator.
Yeah, there we go.
Once you go into that, then you should be able to log in. Yeah, don't do the yeah. Emily, you're right. You don't want to. You want to do graphing calculator, right? And then you put in my username and my password. Are you good? Got it. Okay. All right. So here's what we're gonna do. All right. So there's a function here I designed. It's a piecewise function. All right. And we're gonna transform this. So what we're gonna do is explore 4 different parameters of transformations. Okay. Now, first of all, we can talk about what is a transformation. So in in geometry, when we do transformations, we take shapes, and one of the transformations we do is called a dilation. Okay, and a dilation stretches it. Right. So if you are, making, some sort of, a clothing item or something, and you have a scaled down version and you double it or whatever, right? Because you got to get, I don't know, if you just have it's mainly like a little diagram, but then you got to make it bigger to fit you, but maybe it's for $1 or something, I don't know. But anyway, then you're enlarging it. Okay, so that's a dilation. That's what that's called. The old model cars are a perfect example of that, where you would dilate it down, right? So you'd have a real car, maybe a '69 Corvette, and now you build a model of it, right? So that would be a dilation. Okay, a translation is where you move it. Okay, so you're moving the figure around. A reflection is where you reflect it over a line. Okay, so what we're looking for here is those specific type of transformations, but on functions. So how you set that up is like this. So we're going to go y equals, okay? I'm going to go a times f of b parentheses x minus c parentheses and add a d. So every time that I push a letter, it asks me if I want to add a slider, okay? Because Desmos thinks that you want to make those things variables and you want them to be able to move. Okay, so what we're going to do is click on all right, so that they're all sliders. Now you can see that the red one is a transformation of the black one, right? Because it's not the same location, it's different. So what you want you to do is play with each one of these A, B, C's, and D's. Okay, so I'm going to give you some time to work with these. And then when our time is up, you should be able to tell me what A does. How does A change the black graph? What does it do to it? Okay. B, what does B do? How does it affect the graph? C, how does C affect the graph? D, how does D affect the graph? Okay, so we want to think in terms of stretching, moving, and reflection. Okay, those are the three things. All right, so it should take about, I'm going to say, somewhere between 5 to 10 minutes. I want to kind of see where we are. All right, how do you get the first function? Okay, I'll have to show you. Um, but play with this a little bit and see what each one of those does. Now, I wouldn't recommend playing with them all at the same time to figure out what's going on. If you want to see some cool stuff, yeah, you can hit play, but you can see there's a little play button on the left-hand side. But if you hit it all at the same time, you're going to get a mess. You're not going to be able to figure out what's going on. So I would say use the slider, okay? Use the slider to slide things and see, hey, what does A do? What does B do? What does C do? And then if you want to play around with all four at the same time, you knock yourself out, okay? So, JC, what you want to do is if you're logged in, you go to those three dots and you come down here to where it says transform and you click on that, and that's how you get that graph, okay? So let's just say about let's check with you on 5 minutes, okay, and see where you're at. All right, so I guess everybody's pretty much played around with it. Maybe got all the playthings going, and it's dancing all over the place and changing like crazy. And all right, so let's do this. I'm gonna go back to my OneNote here. I think I should have paused it. Oh well. And share my screen. Okay. So I'm going to write up here, all right, y equals a f x b x minus c plus d. And we'll call this transformations on functions. Okay. So what we want to know, and I want to get this information from you, and you can again, holler it out or chat it to me. What does A do? Okay, and again, in terms of moving, stretching, compressing, reflecting, what does A do? Okay, let's get some more responses. I want to see some more responses. Stretches, good.
I would say A stretches over the x-axis so it can get like bigger. Let's say like at one point it becomes like really thin and then it goes down all the way.
Okay, that's perfect. I'm getting a lot of people saying the same thing. So A obviously is a stretch, or a compress. All right, so that would be a dilation, we would say. So I'm just going to put down here a stretch or a compress. And I also saw some people say that it is a reflection. Okay. All right, so now let's get a little bit more detailed. Okay. So let's say A is becoming larger. Okay. So from 1 to 100, right? What does that do to the graph if A becomes larger? Is it stretching it, compressing it? What is it doing? It's stretching, huh? So if A becomes larger, it stretches it. And JC kind of said it, it's stretching it vertically. Okay. All right. So if A is getting large, then it's taking the graph and it's stretching it vertically, right? So if we were the function, right, and our A became larger, then we would become taller. Okay, we would become taller. You're stretching it out, okay, vertically. All right. So what about in the other direction? Suppose that A is between 0 and 1. All right. Then what happens to it? So we have a decimal.
It gets compressed?
Yeah, it gets compressed. Okay. So if A is between 0 and 1, it compresses it. It compresses the graph.
At 0, it's kind of flat.
Yeah, 0 is flat because it's not, you're right. That's why I didn't want it to be exactly 0. So I stayed away from that, but you're right. 0 is just, it's flattening it. Okay, so what about if A is less than 0? So now we're talking about negative. What does it do then?
The reflection over the axis.
Yeah, that's where you're going to get your reflection over the x-axis. All right. So A has a lot going on, right? I mean, it's stretching it vertically. You can get a stretch, you can get a compression, you can get a reflection. So A has a lot. Yeah, A's got it going on to the right. Okay. So there's a lot going on there with A as far as how it affects a function. All right. And it's always going to be in this format. All right. With the A is going to be in front of that F, whatever that function is. That's where A is going to be. It's always going to be in front. So whatever number's in front of the function, this is how it's going to change it. Now, I want to skip B for a reason. I want to come back to it. All right. So if you got to have everything in order, skip down, 2 or 3 lines, and we'll do C. All right. So I'll do it. I'll just go ahead and put C down here. But you might want to skip down a few lines if you got to have everything in order. All right. So what does C do?
I believe C moves it across the x-axis in a horizontal way.
That's right. So it's moving in horizontal. Okay. So this is a move or a slide or a translation horizontally. Okay. Now, we got to be, I'm going to put down here, by the way, C units. So what do I mean by that? You have to be careful with this one, because if we go back up to this equation, I'll come back down to where I am. All right. I see in here that we have a x minus c. All right. So if I take a function, so I'm going to kind of write off to the side here. All right. So if I take a function and go f of x plus 2, right, which way is it going to move that? Is it going to move it 2 to the left or 2 to the right?
To the left.
To the left. You're right. Okay, so it's going to move it to the left. Okay. If I go f of x minus 2, which way is it going to move it?
To the right.
To the right. Okay, good. So you see, it's kind of the opposite of what's in there. And the reason why that is because if we have f of x plus 2, we can rewrite that as f of x minus, okay, a negative 2. So this negative 2 is the units that the function is moved. And since it's 2 to the, and it's a negative 2, it's going to move it back to the left. All right, because that's where my negatives are. So when we see this plus 2, we can't automatically assume that it's going to move to the right because it's positive. No, that's not the case. Because inside that original slider expression I wrote, I made that a minus because that is what it is. So that means that it's always going to be the opposite. So if it's an f of x minus 2, it's going to go to the right. If it's f of x plus 2, it's going to go to the left. All right. So that's why I said it moves horizontally C units. If you just look at this here and see that it's x minus c right there, so you know that whatever that is, okay, it's going to be the opposite. That's just how it works. All right. Kind of confusing, but that's how it works. Oops. All right, so let's do D now. Okay, I keep writing it. Let's do D. Okay, and what does D do?
D is the vertical translation.
So D is a vertical translation. Okay, we need to fill up these chats. Everybody, a lot of people should be responding, so I know you're getting there. So this is going to be a move. Okay, vertically. If we were in class, that's what I'd want everybody replying here. Okay, and that's going to be D units also. All right. Okay, so now we've got it figured out. We got A. We know A does a lot of stuff, right? It's stretching, it's compressing, it's reflecting. C and D are your moves. Okay, C is moving horizontally, D is moving vertically. So the question is what B does. Now B is really hard to see. All right. So what I'm going to do is jump into Desmos real quick here and go into look at this. Okay. So here I'm going to make A1. There we go. And C0 and D0. There we go. All right. Now, when I take B and I change that, it looks a lot like A. Okay, it looks a lot like A because it's kind of stretching it. But you see how it's really not moving it upwards at all, stretching it upwards? Okay, so instead we have a stretch, but it's horizontally. Now what's crazy about this, and for those you're going to take 112, you're going to see this a lot more in 112 when you start drafting trig functions. So this B is right now is 5. So you would think, man, if that's, wouldn't that be like stretching it out 5? So wouldn't it be like 5 times wider? It doesn't work that way. It's actually in a reciprocal relationship or an inverted relationship. So instead of stretching it 5, it compresses it 5. So it's actually like 1/5 of the size horizontally. Okay. So instead of being wider, it's thinner. And the same thing happens when I make this a decimal. Okay. Now look at that's 0.3, but man, it's way wider, right? So it's 0.3, which would be 1 over what is that? Almost a third. So it's like 3 times the size. All right. So that's what B does. If we make it negative, you're not going to really tell a difference because what it does is it reflects it. And it reflects it over the y-axis. But you can't tell because the graph's metric. Okay, so you can't really tell that that's what's going on. But if I didn't make it symmetric, it wouldn't be very pretty. All right, so that's what B does. Okay, so B is very similar to A, except B does its stretching and compressing horizontally at an inverse relationship, and it also reflects over the y-axis. We don't do a lot of stuff with B in this class, but you will in 112 if you're going that way. So here, let me put that on here. Okay. So what does B do? Come on. There we go. So B stretches horizontally. All right, reflects over y-axis when B is less than 0. Okay. So that's what B does. So now you know. I'm not sure that you got all those, so I'm going to kind of shrink the screen down a little bit so that you got the whole thing there. I think. There you go. That's as good as I can get it. So now the question is, okay, what do I need to know to do the assignment, and what kind of things are going to be on the test, right? Because that's what everybody wants to know. All right, so let's say that you have a U shape, all right? So I'm just going to draw a nice little parabola. Y equals x squared. Okay? So what it's going to ask you to do is either describe, let's write this down, describe the transformation. It might have you graph the transformation, describe the transformation, and sketch. Okay? So let's look at that, right? So here I'm going to put some down here. So let's go. Now I'm going to change this just a tad bit here. Let me do f of x equals. Sometimes what they'll do is they'll go like this. So they'll go, okay, y is equal to 2 times f of x. All right. So f of x is x squared. Is that first thing we want to do is look at it and go, hey, is that my a, b, c, or d? So which is it? Is the 2 a, b, c, or d? Yell at me or throw it in the chat just to chat it up. A, good. Yeah, that's your A. Remember, A's out in front. It's always out in front of the function. Okay? So now as you know what it is, right? You go, okay, see, let's see, that's 2. So it's not a really big number, but what is it going to do to that function? Chatter, there we go. Chatter reply. Stretch, very good. It's going to stretch, yeah. Okay, which way is it going to stretch? Vertical, yeah. It's going to stretch vertical. So if it's asking you to describe this, then you're just going to say, this is a vertical. You have to make sure you say it's a vertical stretch by 2. All right? Now, if it's asking you to sketch the graph, okay, it's just going to stretch this thing. So then it's going to kind of go like this and like this. So you're going to make it a little bit narrower than what it is. Okay? That's the sketch. And that's what you're looking for. All right? Now, in the first couple problems on the assignment, it gives you some equations and you got to match. Okay? It's the same type of idea. You just look to see, okay, what's the transformation and which one fits the graph. Okay, so it gives you the equation and it gives you the graph and you got to match it up. All right. Okay, let's look at another one. So the same thing, same U shape. I'm going to go like this. Y equals negative f of x minus 3. All right, so now I have two things going on here, right? So if I was to describe these transformations, what would I say? I got to reflect, very good. So I have a reflection, good job, over x-axis, good job. What else we got? Moves to right. How much?
3.
3, yeah, good job. Okay, good job, there we go. Okay, so then we're going to reflect over the x-axis and we're going to move at 3. All right. Now, so that's what I would say is I'm going to reflect over the x-axis and moves 3 units right. Now, if you said 3 units horizontally, I would take that. All right, I would take that. You don't necessarily have to say the direction. But if this was an x plus 3 and you said it moves 3 units horizontally, then I wouldn't. Because 3 units horizontally means it's going to move in the positive direction. You would have to specify whether it's positive or negative 3. In this case, remember we said it's going to be the opposite. So that's 3 units to the right. Okay, so what is that going to look like? Well, it's going to be reflected. It's actually going to you know it reflects over the x-axis because the A is a negative. Okay. All right. So then what we're going to do is we're going to move this over 3 and reflect it. move it over 3. And we'll talk about the order in a little bit. Okay, so then it's going to reflect. So I want to reflect it, so it's going to look something like this. Okay. Now the ones, well, I shouldn't say that. Well, pretty much. All the matching ones are pretty much just one transformation. Okay. So let's try one more, and we're just going to describe these. So let's go with f of x. Let's put x plus 1 and a plus 2 on the outside. Okay, so what's happening on this one?
It's moving up 2.
Up 2. Okay, so we've got moves up 2. What else?
Left 1.
Left 1. Very good. Left 1 up 2. I see that. Good. Moves up 2. Left. Okay, 1. Okay, you could say horizontally -1, because that -1 means that it's moving in the left direction. All right. So I don't really care how you say it, but you want to make sure that you're telling me left or right. Okay. All right. Good. That's good. Let's go the other way. So what do I mean by that? So let's say that we have a function f of x. Okay. And now what we want to do is we want to write the function with the following transformations. So let's say, and I have, my first one is going to be a reflection. Reflection over x-axis and up 3. Okay, so what I want to do now is write what this function is going to look like. So I'm going to start out with y equals. Okay, so what do I write now? And you can put this in the chat, because you can put f of x's in there, or you can tell me. Take a guess at it. It's okay to be wrong. It's not like you're getting graded on or anything. There we go. Now we're getting some responses. Nice job. There we go. Sweet. Okay, so I'm kind of seeing the same thing here. So we're going to have a reflection. So we're going to go with a negative f of x, right? Okay, we have an up 3. So we know that's my d. And there it is. All right, so I have no stretching going on. It's just a negative f of x. The negative out in front is the a. So that's going to give you your reflection over the x-axis. Plus 3, that's your d. All right, good job. All right, so let's try another one here. Let's go with a vertical compressed of 0.3, 0.3. And let's do a horizontal move of 2. Okay. All right, here we go. What are we going to get? Y equals, here we go. Oh yeah, that's nice. Good. 0.3s are a. All right, f of x. So move of 2, so that's 2 in the right. So then we want to make that look like that. Okay, good. So you can go either way with it, and they're going to have you do that. All right, they're going to have you do that. Questions on anything we've done so far with this transformation stuff? It's not easy, so don't think that you're, if you have questions, ask.
When we write the formula, do we have to include the f? Or would it be also correct if you put like 0.3 parentheses x minus 2 without the f?
In this case, you'd want to put the f, but you're asking a good question. So what if they said that f of x was, say, I don't know, square root of x, right? So let's say that they told you what it was. And so then let's say that we want to do a reflection over x-axis, a vertical stretch. I'm going to abbreviate that, vertical stretch of 2, and a horizontal move of -1. Okay, so then what you'd want to do on that is actually you're going to use that square root. Okay, so the reflection over the x-axis with a vertical stretch of 2, so it'd be a -2. I'm going to go y equals -2 out in front of my square root. All right, I got a horizontal move of -1, so that means I'm going to go x plus 1, and I'll make sure that square root goes past that a little bit. Okay, so if it gives you the actual function, then you want to write it with that actual function. Okay, questions on that part? That's a good question. Okay, so now what I want to do is I'm going to go back and almost back to where we're doing the t-charts again, and I want to talk about how functions are multi-transformations. Okay, how do we do multi-transformations, or how does that work? Okay, so let's take a look at multi-transformations. I kind of did that a little bit, but I kind of used some math magic there and didn't really explain anything. So now I'm going to show you what's going on, okay? So transformations. All right, so let's say that we have f of x equals, let's do a absolute value of x, all right? And so what I'm going to do is do y equals, I'm going to go -2 absolute value of x plus 3. Okay, so something like this. So this is we'll do 1 with 2, and then we'll do 1 with 3. Now also notice I haven't done anything with b's. Okay, and again I'm trying to stay away from those a little bit. I will show you one with a b so that you kind of see how that works. All right, so here is what our absolute value function looks like. All right, in case you don't remember, I'm going to put it in blue here. So your absolute value is a v, okay? So it looks like that. That's what an absolute value function is. So what we're going to do is graph the transformation, okay? Now, if I was you, I would kind of wait a little bit, watch what I do, and then go from there. Okay, so I'm going to go -1, or excuse me, -2, -1, 0, 1, 2. And I'm going to put that in here, and I'm going to make it a little different. Okay, so these are my x's, all right? So then what I have to do is figure out, well, what transformation do I do first? Do I reflect it and double it, and then add 3? Or do I add 3 and then do reflection and doubling? Because when you, either one of those, you're going to get different transformations. You're not going to get the same thing. So you kind of got to know what to do first. So let's talk about this. So if I have a -2 and I put that -2 in for x, right? What would be the first thing I would do besides take the absolute value of it? Then what would I do? Would I multiply by 2 or add 3?
Multiply.
Right. Remember the order of operations? Order of operations says you do multiplications and divisions before additions and subtractions, okay? So then this means that I'm going to take a negative 2 with the absolute value of negative 2 like that, okay? So that's going to give me, absolute value of negative 2 is positive 2. This is going to give me a negative 4, all right? Then what would I do with that negative 4?
Add 3 to it.
Yeah, now I'm going to add 3 to it, so now I get negative 1. So my final thing is negative 1, okay? Now I'm going to kind of keep this going. So let's start with negative 1. So negative 1 is going to go into that absolute value like this, right? Absolute value of negative 1 becomes a positive 1, so that'd be a negative 2. But then what am I going to do with the negative 2? Yeah, add 3. Very good. So that's going to give me a positive 1. Okay, good job. All right, now I'm going to do the same thing with the 0. So really, I just kind of want you to kind of watch a little bit. All right, you don't. I mean, I don't even care to write this down, but so negative 2 times 0. All right, well that's just 0. But then what is it going to be? Then what do I do for a final? What's going to be my final point there?
3.
3. Okay. So I'm just going to kind of continue with this for right now. All right, I know that's a negative 2 because it's the same as up here. I know this is going to be 1. All right, I mean, it's not going to change because you're just changing the positive to a positive. It's a negative 4, which is a negative 1. Okay. So what's happening is that we're taking this graph and we're going to do the negative 2 part first. So the negative 2 part, first of all, is going to reflect this thing, right? So then instead of it being up here, okay, it's going to reflect it. But it's going to reflect it and stretch it. So 1's going to become 2, 1's going to become 2, and 2's going to become 4, 2's going to become 4. So this is going to be a vertical stretch. Now that's only the first part of this, right? So there's my vertical stretch. To finish this graph, all right, let's see, I'll put this in orange. To finish it, I would move it up 3. So this 0 goes up to 3, all right? And this 1 goes to there. And this 1 goes to that 1. And this 2, which was at 4, goes up to 3, which is 1. So now I get this graph right here. Okay? And that's how you do a multi-step transformation. You don't have to make the T-chart thing, not at all. But what you do have to understand is, what are we going to do first? Are we going to do this first or this first? Okay, but follow your order of operations. Do your multiplications and divisions, and then your additions and subtractions, and you can't go wrong. All right, so that's how it works. Now let's try another one. All right, you don't really need the table. You just got to know what's going on. All right, so let's draw this. And notice, see what I would do if I was doing these is I would do that first transformation real light, maybe in a pencil or something. Okay, and then go over the other one darker. Your final answer darker. All right, so let's do something different now. Let's stick with the absolute value. That's kind of a good one. All right, so I'm going to go like this and go like this. Okay. So now let's say we're going to go y equals, let's go with a 1/2 absolute value of x plus 2 minus 1. Okay, so we got all kinds of things happening here, right? This is about as many transformations. I'll do a b next, and then we'll be done, all right, that you can have. So again, we got to ask ourselves, I wonder what we'll do first in this case, right? So if I know what x is, would I multiply it by half? Would I add 2? Or would I subtract 1? What do you think? Suppose we knew what x was. What would we do first? Okay, we got 1 multiply. We got 1 divide. Let's make add 2. Multiply by half. Add. Okay. See if we can get one more response here. Add 2. Okay, good. Yeah, if I know what x, if I say x is 1, then I'm going to do what's inside here first, huh? So I'm going to add 2. So that means that I'm going to take this blue absolute value function and I'm going to move it 2 units. Now, here's the question though. Which way am I going to move it? Left or right? Yeah. Good job. We're moving it left, right? Because it's a plus 2. So I'm going to take this point and I'm just going to go like this. Okay, so now I'm going to take and draw this thing like this. I'm going to draw this like this. Okay? So now I have that. But that's not my final answer. Okay? Now, we got the 2 taken care of. What are we going to do after we added the 2? Now what are we going to do? Are we going to multiply by half or subtract 1? Have it. Good. Multiply by half. Oh, awesome. Okay, so you're seeing it now, right? So we're going to multiply by half. Well, what does that do to the graph? Yeah, it's a compression. Good. So I'm still going to have this same point, but instead I'm going to kind of widen it out a little bit. Oops, let me change the color. I'm going to widen it out a little bit. Okay. So instead, I want to widen this out. So let me change this to like this light blue, I guess. So now I'm going to kind of widen it out a little bit. And see, I'm just kind of sketching this. All right. If I want an accurate sketch, I'll put in decimals. But here I'm just sketching it out. All right, so there, I took care of the 1/2. Now what do we do with this thing to finish it off? Down 1. Hey, sweet, we're going to subtract 1, right? So I'm finally going to finish this. I'll finish it off in green, I think. So all I'm going to do now is take that blue graph, right, that light blue, sky blue there, and just drop it down 1. So here's my final answer, okay? I don't really need this pink and blue anymore. All right, I'll leave them there so you guys can see it. But that's how you do it. All right, so that's how you do a multi-step graph. If we have a B, okay, when you have a B, understand that that's different. This was an A, okay, and this is a B. All right, so the B is on the inside. Now, it does goofy things with that absolute value, okay? Because remember, it seems like it would stretch it out horizontally, but it doesn't. It's actually an inverse relationship, and then it inverts it. So let me show you kind of how that works, all right? And then we'll be done. So let's say we start out with these guys again, like that. So -1. So -1 is going to take and multiply that by 2. So that would be the absolute value of -2, which is 2. 0 is just going to be 0. 1 is just going to be the same here. It's just going to take 2. So that's 2. And 2 is going to be 4. So that's 4. And I should have put -2 in here. I'll just put it down here. But it's going to be the same thing. So that's going to be -4, which is going to be 4. So when I graph this, right, I'm going to get 0, 0. That doesn't change. But 1 is going to be 2. So see how it's kind of compressing it inside. Okay, so it's bringing it out like that. So now I get a narrower V. All right. So yeah, that's how it works. Because you're doubling it inside, and then you're applying the function, that's why you get that inverse relationship. So it's kind of goofy. Why did we add 2 first? Daniel, which one are you? Oh, up here? You're asking me about this one?
Yes.
Oh, well, because if, let's say, let's say you were making that little chart, okay, and you put -2, -1, 0, 1, 2. You would start with -2, so you would put that in that for that x. So if this x was -2, what would you do first?
-2 plus 2.
Yeah, see? There you go. You answered your own question. That's why. Okay? You would do that. So that's what a b does, okay? But you have to be careful and note the difference between when the 2 is on the outside and when the 2 is on the inside of that function, okay? All right. I think that's pretty much all the stuff that I see on here. It's probably going to be a little bit, I mean, I guess I would anticipate it not coming easy. So if you have questions on stuff, you can always ask the next class. But I kind of want you to play with them a little bit and work with them and see what you come up with. All right. But I don't want you, hey, if you struggle a little bit, then just pass it and we'll answer your question on Wednesday. But yeah, so work on them a little bit, but don't beat your head over them. Okay. Questions on anything on transformations? So as far as the test goes, transformations, I'm probably going to give you a graph and have you do some transformations on them. And then I think that's pretty much it. So it'd be more like, here's a graph, do a transformation, or describe transformations, that kind of thing. That's kind of what I'm looking at. And I will try to get the review up there for you tomorrow. So I'll make an announcement. I also went back and did the quizzes and checked to see if I could make it so you can see it. So I checked a couple boxes. I don't know. You can let me know if it works. Not tonight, but sometime. All right. Will these work in Desmos? Yeah, I mean, you can graph them in Desmos. I don't know what the average score on the quiz. They were good, so didn't worry too much about it. Yeah, you can do that. I think that's fine to check your stuff, but I think you kind of want to be pretty good at transformations and understanding them rather than just typing them in, if that makes sense. Good questions. Anything else? All right, then. So remember, if you haven't submitted the assignment with the 27 and 61, to go ahead and do so. And otherwise, have a nice day tomorrow. Do we still have time to turn in 1.1 through 1.4? You still have time to turn in 1.4. You can turn in the other parts again, but if they're late, they're going to be 3s. But again, 3 is better than nothing, which is what I said in the beginning of the period, or the beginning of the class. Always turn it in. It's better than nothing. Hold on here. Yes, I will, but later we'll talk. You can email me when you're ready. Yeah, you too. Have a great evening. I want to stop this, and I'll hang out if you have questions.
Thank you very much.
You bet. See you, Spencer.
Thank you.
Yeah, you're welcome. See you. Have a good evening.
Mr. Patterson, I don't think I was here when you went over 27 and I think it was 60. No.
I didn't go over those because I went over piecewise functions, and then those are piecewise functions, so you would just apply the stuff on piecewise functions.
The 27 and 61.
Mm-hmm. That's what they are.
Okay. I guess I can do those right now.
Try it out, yeah.
All right, thank you.
Yeah, you betcha.
I already turned in the homework for 1.4, so should I turn in 27 and 61 separately somewhere else?
Taylor, so if it doesn't let you submit it to that assignment, just email it to me, okay? Yes, you
Okay.
should though.
Okay, thank you.
Can you kind of go over an overview of how to approach the problems with conditions, especially for 61? It kind of feels like, well, where do I start?
Sure. Did you get my little message?
Which one?
The one where I want to chat with you anyway about some questions you had.
Just the emails, yeah.
Okay. Oh, no, okay, this was a chat, I think. Hang on for a second. I just got to take care of this one here. Okay, so Danielle, let's see. You wanted to ask me about 61 and 63. Which one was it?
Yeah, about 61. Because I always seem to miss a portion. So I see the first part is that I should input the wind speed where the variable v is.
Okay, I'm heading back that way here. Let's see. Gotcha. So 61. Here, let me do this. I think I'm gonna do it this way. Okay, so here's 61. So we're gonna, let's see. So we want air temperature. Let's see. V is wind speed. T is air temperature. C is okay. So an air temperature of 10 degrees Celsius and a wind speed of 1 meter per second. So V is the velocity of the wind speed. So that's where your condition is going to be based upon your wind speed. Are we okay with that?
That's helpful, yeah, velocity of wind speed.
Okay, so V here represents the wind speed. So since the wind speed is 1, okay, I come up here and I go, okay, which one of these conditions does the 1 fall in?
So v is less than c.
So in other words, is V between 0 and 1.79? Is it between 1.79 and 20? Or is it greater than 20?
The first one.
Right. So since V is 1, okay, it falls into that condition, which means we're going to use this, okay? So whatever the T is, which is the air temperature, so that's 10, that's what the answer would be. So number 1, or excuse me, A, is 10. You know, so a wind of 1 meter per second doesn't really affect the temperature very much, which is, you know, that's not very much wind, right? So now if we move to the next one, I still have 10 degrees Celsius, but now my wind speed is 5 meters per second. So then I come down here and I go, okay, which one of these conditions does that particular velocity fit?
The second one.
Yeah, there you go. So it's in the second one, right? So then now that V is 5, I use this crazy formula right here, right? And I type that in. So, but my V is 5. So wherever I see a V, I'm going to put a 5. So I definitely put this in the decimals. I think I might be able to have it here. Where's my, see if I can get decimals pulled up. Oh, I guess it is here. Let's go like this. Let's go like this. VES, MLS, graphing calculator. All right, so now I'm going to put that formula in. So let's see, that was 33 minus 10.45. 33 minus parentheses 10.45. You gotta go back. Plus 10
Squared B minus B.
square root, and it was 5, right? And then minus 5, right?
Right.
And then what do? I divide it by something?
Parentheses 33 minus T. Temperature.
So is that on the bottom? Or no?
No, that's in the
Okay.
numerator.
So is it in a new parentheses like that?
Yeah, and then it's 33 minus the temperature.
Of 10. Okay, something's not right because it's giving me negative 606.
That's over.
Oh, that's
22.
over. Okay, so this is over. Like this?
22.04.
22.04. Okay. All right, that makes more sense. So see, that's about 4 degrees then.
Oh, okay. I was wondering about the answer it gives out for you. So that's kind of like calculating for you.
Yeah, it is. It's a calculator. You just don't ever have to push equals.
Okay. Okay, that's helpful. So determine the velocity, find what condition it fits in, and then go from there.
Right. So then, yeah. So you just look at, see now the airspeed's 15. So you're going to do the exact same thing. Right. You could even go back in the decimals and change your. So if you went back into here, you could say, oh, now I'm going to make this 15. Right. So I don't have to retype or figure out anything. I'll just put. And now I get negative 2.6.
Okay. Awesome. Thank you. I won't make you do them all.
Oh, that's okay. Whatever you want. I think there's really only one more, and that just asks you the physical meaning of the equation corresponding to, the equation. Let me go see what the equation is. If it's.
Is that like describing it?
I think I don't explain the physical meaning. I think basically that they're saying, because if you graph that, I bet that the T is just a regular temperature. That's just going to be linear. The other thing, you can't even graph that because you don't know what T is. Okay. Yeah, so I think my guess is that the larger the velocity is, the bigger the effect on the temperature. I think that's kind of what they want you to think about, which makes sense.
Right.
Yeah. And I'm thinking that the effect of the third equation is more drastic than the middle one. I'm thinking that's what they're trying to get you to see. But you wouldn't really know that unless you graphed it. It'd be a heck of a piecewise function to make, though.
Okay. Thank you for that. That was
Hey,
really helpful.
You're welcome. But you had some questions on Well, I can't. I have to go back and look at your. Do you remember what you were asking me in your email that I read it and I said it'd be best if we answered on one-on-one. Do you remember kind of what that was about?
Was that the email from today?
Yeah, I think it. I didn't. I looked at him this morning or this kind of early, late morning, and it wasn't anything. But then I saw it like during class. I can't. I have to. I mean, I have to go look and see what it was.
Yeah, I have to look at it as well.
All right, here we go back to. Let me get this out of the way.
Oh, I see. Okay.
Clear everything out of here.
Oh, okay. So for 56, and for 56,
Okay.
and then for 77.
So those pages, right?
Yeah, those are the pages.
Okay. So what was the
For
question of?
56, I gave you an example of how I gave the answer for 43, and I'm not sure if that's what you were looking for, like that format.
Yeah. I think your questions was regarding the assignment stuff that. And were you able to see the comments that I made? Is that what you were commenting back on?
Oh yeah. So you had mentioned that 23 was incorrect, but I was wondering if you meant 21 instead, because there's no 23 on that assignment.
Um, on page 56. Because I have 23 through 37 odd on that one.
Let me check the assignments really quickly.
Okay. I don't think it affected your score though. I think your scores were okay.
Yeah, it didn't. I just wanted to make sure I corrected the right
Yeah.
one. It was for page 63.
It's 63?
Yeah.
Not 56 then. Okay.
Page 63.
On page 63, it was 13 through 22. Yeah, there was no 23 in that one. If I said 23, I don't know what I was saying there because we didn't do 23 on that page.
And I'm a little bit confused too because I'm looking at the syllabus, the actual paper document, and it says page 64.
Yeah, it says 63, but I think it starts on 63. The assignment kind of starts on 63. I mean, like here, but we didn't have to do 11, right? So the actual problems start on 13, but the assignment starts on 63. I think that's what I have.
Okay, it's just a little bit different when they're broken down in D2L.
Yeah. Was there other ones too that you were asking me about?
Yeah, 77. I didn't understand 77. 57 through 60, because we went over that example in class, and you had mentioned that there's an open circle, and when I was doing 57 through 60, I don't know how I would have known it was an open circle.
Well, hold on for a second here. Oh, I gotta do